In example B, we want to find the area between the function f of x equals negative x squared plus x plus 2 and the x-axis on the interval between 1 and 4. This area has intervals both above and below the x-axis. If we were to graph this on Desmos, we would get this parabola here. Notice some of it is above the x-axis, some of it is below the x-axis. And to show you kind of where the shading is going to be between 1 and 4, you don't have to worry about ever doing these in Desmos, but I'm going to put these in so you can see what we're talking about. Between 1 and 2, the graph is above the x-axis, so it would have a positive area. And between 2 and 4, it's below the x-axis. So this green part here would have a negative area. We can determine that value by hand by setting the equation equal to 0 and finding out where that x-intercept is. So we can divide everybody by -1 and factor the left, and we would get two values. We have an x-intercept at 2 and an x-intercept at -1, but because our interval is between a positive 1 and 4, this guy doesn't matter. So we can take the integral from 1 to 2 of the function, negative x squared plus x plus 2, and then subtract from 2 to 4. And again, we are assuming that we're looking for the total area and not the net. This is a lot of work by hand. So again, I will let you use your calculators. So in Desmos, we can actually do the integral, but we're only going to do the first piece from 1 to 2. Notice in the graph, that is the interval where it's above the x-axis. And we can just type in f of x, since the function's already defined in there, minus the integral from 2 to 4, because that is the interval where it's below the x-axis. And I forgot my d of x for both of these here. There we go. And notice it gives us 9.833. If you want the exact answer, notice you have this fraction bar over here. If we click on it, it will give us 59/6. So we can go from the decimal version to the fraction version really easily again through Desmos. Example C has an area that is completely enclosed, and it's enclosed between f of x equals negative 2x squared minus 5x plus 3 and the function g of x, which equals 2x squared plus 3x minus 2. Again, we need to know where it is enclosed. So to do that algebraically, we can set the two equations equal to each other and solve. It is factorable. So it is bounded in between the values -5/2 and 1/2. Well, 1/2 is the highest value. -5/2 is the lowest, or the left value. But we also need to know which graph is going to be higher than the other. Well, keep in mind what these polynomial graphs look like. The f of x function is a negative quadratic, so it's going to open downwards, whereas the g of x function is a positive quadratic that's going to open upwards. The only way these two functions can be bound or make an area that's completely enclosed is for the f of x function that's opening down to be above and the g of x function that's opening up to be underneath. So we're looking for that area in between. So we will take the function of f of x minus the function of g of x. We can do a little bit of algebra to make this a little simpler if we distribute that negative and then combine like terms. Again, we can put this in our Desmos, and we get an area of 18.